Renault from Hortonworks. He will give you an introduction to Hadoop. Have fun.
Thank you very much. So, as you mentioned, I'm Olivier Renault. I work as a solution engineer for Hortonworks. I've joined Hortonworks at the beginning of this year. I'm myself still a bit discovering Hadoop, so bear with me. That's why we're doing only an intro. Maybe next year we do something a bit more advanced, but here we go. So before I jump into Hadoop quickly, I'm just going to quickly present with Hortonworks. And to present with Hortonworks, what we like to do is to look a bit at the history of Hadoop. So Hadoop got created in 2005 in Yahoo, okay, based upon a white paper which was written by Google about how to process a large amount of data in parallel, okay. So it was created by a guy and his team. The guy is named Eric Balderschwiller, and we know him most often under the name of E14, because Balderschwiller's got 14 letters, effectively. And they started in 2005. They released it as an open source project in the Apache Software Foundation in 2006. And pretty much they've developed this project along with Yahoo, inside Yahoo. From 2006, it got picked up by other companies, such as Facebook, such as Twitter, and so on and so forth, and it started to have some growth outside just Yahoo. And pretty much in 2008, they looked at their growth of Hadoop, and so that 2008, they were reaching a number of clusters which were around 20 nodes, 30 nodes. And they looked and they're starting to see that within Yahoo, the usage for Hadoop was starting to grow and grow and grow even further. And it was going to grow to a large scale, so they started to focus on how to operate a cluster at scale. Just so you know, right now, the amount of Hadoop node within Yahoo is around 75,000, okay? A cluster for Yahoo is 4,000 nodes on Hadoop 1.0, and they're starting to run Hadoop 2.0 on a cluster is 15,000 nodes right now for them. Okay, so when you start to having this kind of scale, you need to think about how you're going to operate and how you're going to manage it at this kind of volume. In 2011, Hadoop got used even further, and the world of the enterprise started to get interested in Hadoop. And so Hortonworks got created at this time, and it's pretty much, so Eric Balderschwiller, which was at the beginning, which left, plus 24 is a key Hadoop engineer, and created Hortonworks. Okay, the focus is to arrive into stability and provide enterprise distribution effectively. So Hortonworks we do three things. We still develop quite extensively. We distribute, and that's what we provide. We provide an Hadoop distribution, which we call HDP, Hortonworks Data Platform. And after that, we support. We work with few partners. One of them is a customer of ours, and he still is Yahoo, but it's also a partner for us, so it's also developing partners. So we work with them on the features and on the roadmap, and they also give us access to their cluster in order to do our QA testing. Okay, so before we launch distribution, we've got the opportunity to test our distribution on the 4,000 node cluster of Yahoo. So when we say that we test our distribution at scale, we actually do test it at fairly large scale. We've got also a company which is well famous for this love of open source, Microsoft. That's also one of our partners. It's kind of strange to see Microsoft coming into the picture, but Microsoft tried to bring Hadoop for a year and a half. They tried to port Hadoop on top of Windows, Hadoop being just Java, write it once and run it everywhere. It should have just worked. They struggled and they came to us for some help. What's interesting is that now Microsoft is also providing quite a lot of input on how to optimize some of the work which has been done. So they are trying to arrive to the table, and they're trying to arrive to as a committee as well. We then have Teradata and rack space in the cloud. Then the way of seeing why Hortonworks is contributing quite a lot of the Hadoop project is that the green bar, that's the amount of line of code that we've contributed to the project. So yes, we are a heavy developer on this project. The second contributor is Yahoo. So when I was saying that Yahoo is still a development partner for us, that's Hortonworks, Yahoo, and then the third player, which is Cloudera. Okay, so we're quite heavy on this part. As part of HDP, what do you get? But you get, obviously, Hadoop, and Hadoop, it's made of a distributed file system, HDFS, and a parallel processing engine, which is called MapReduce. Okay, so that's what we call the Hadoop core. You've got now also something which is called Web HDFS, which is a REST API in order to bring your data onto the HDFS file system. And with Hadoop 2, what we're all waiting for is something called Yarn, yet another resource negotiator. And the beauty of Yarn is that it's going to take away from just being a MapReduce solution. We are going to be able to do multiple other applications on top of that. So I don't know if you've heard from Storm, from Twitter, which is a streaming engine, effectively. With Yarn, we will be able to run a MapReduce, and on the same cluster, run a Storm cluster. Okay, so that's going to be fairly interesting. Then we provide, as you probably know, the name node in Hadoop 1.0 is a single point of failure. So as part of our solution, we also provide an HA solution for the name node. We've got disaster recovery, snapshot, mirroring, and so on and so forth. What we do is everything we do is actually under 100% open source. So everything we do, we give it back to the community. Okay, so it's not something which is it's developed by us, but then it's available for everyone else. So that's pretty good. You can go and download it directly from the website, okay? So there's a lot of data services around on top of Hadoop because MapReduce is initially written in Java, okay? So you need to write your MapReduce in Java most of the time. I don't know about your Java skill, but mine are equivalent to none. So thank God for that. There is some other options which are available, and two which jump to mind are Pig and Hive, and we will speak about Pig and Hive in a bit. There is also HBase, which is available, which is an NoSQL database, okay? And Flume and Scoop. Flume is when you want to stream some log file into HDFS, and Scoop is to be able to export some data from a standard RDBMS database into Hadoop and export from Hadoop into another RDBMS database. Then we've got some operational services, and that's Ambari and Uzi. So I will do a demonstration of Ambari a bit later. And Uzi is a scheduling engine. See it as a cron job if you want. You can schedule all of your Pig and Hive job and your MapReduce job to happen in a certain manner. So when the data arrive in HDFS, you can just take some action based upon Uzi, effectively. And all of that is what is HDP. Run on top of Linux, run on top of Microsoft as well. That's a partner. We run in the cloud, in the VM, or as an appliance, okay? And in terms of marketing blobs, that's finished, all right? So quickly, an overview of Hadoop. So first, it all started at Google, okay? So Google needed a way of doing page ranking, so they wanted to see all of the links and how the links are going in between the different web pages in order to, when we do a search, provide us with something which is relevant to our search effectively, all right? A way of looking at it is that's pretty much the idea of so Google wrote this white paper called MapReduce, Simplified Data Processing on Large Cluster. They put it out, and pretty much that's the idea. So you've got two phases, your first mapping, and then you're reducing it. So if you look with an example, we're going to look for all of the URL where there is the word books, okay? So we are looking at this URL. When we find the word books, we linking all of the URL all together. So you've got books in this URL and on that URL. And that's pretty much what the MapReduce concept is all about, okay? Is to be able to do some key value kind of solution. With this kind of work, what now people are able to do is, for example, to look at all of the weblog which are being generated when people are using your website. And based upon the information of this weblog, being able, for example, to do a recommendation engine. Okay, so you've all gone to Amazon, you've all bought from eBay or from whatever. And when you search for something, there will always be some stuff that you search for, and then some other products which are fairly relevant to your search. An example is that, for example, my dad is a fisherman, so I looked for at some point to buy a rod for his birthday. And I didn't buy the fishing rod, so for a wee while, eBay was convinced I was really much into fishing, and they were pushing me a lot of advertising about, either the string for my fishing rod or the special boots to go fishing or whatever it was, Fortunately, I was actually not really that much into fishing myself. But anyway, that's another story. Okay? So, the idea of Hadoop is that, so you've got the map, you've got a shuffle phase, and then you've got the reduce. The shuffle phase is this phase where we are linking all of the books together. The beauty of this MapReduce paradigm is that you can work into a lot of systems at the same time. It's parallel processing, effectively. Okay? So Hadoop is made of two components initially, HDFS and MapReduce. So let's have a quick look at how HDFS works, effectively. Well, that's a cluster. So we've got some nodes which are the master node on the side, that's the blue node. And then we've got a lot of data nodes which are in a rack, and Hadoop's got this knowledge of rack awareness as well, so it will know where your nodes are located, and it will make sure that your blocks are not on the same physical box or within the same physical racks in order to make sure that if your stuff crash, it doesn't work. So that's the HDFS part. So HDFS, first it's a distributed file system, so we don't have a SAN at the back end. We're using standard pizza box in order to have that. Some key assumption. Hardware failure is a norm. Okay, so the file system itself is planning for hardware failure. It's made for high throughput, and it's an append-only file system. So it's something which is really good. You write it once, and you read it many times. And what we're trying to do is HDFS and MapReduce is to have the computing power to be close to the data. Okay, so that's one of the important part of it. When you run an HDFS, you've got few components, and that's when you look at you've got first the name node, and the name node is effectively holding in memory all of the information of where your data is located. And when I say that is a single point of failure, that's kind of an issue, because when you were losing a name node, your data wasn't lost, but you were not able to access it. Which, if you're like some clusters that I know of where you've got 5 petabytes of data, suddenly you can't access your 5 petabytes, it's an issue. Then you've got another one which is called the data node, and the data node are effectively the worker node. Okay, so the one where you store your data, and it's where you're going to do your MapReduce processing. They ping every so often the name node in order to make sure that to tell them that is there alive, and they will also report the blocks that they've got available on top of them. And then we've got a third node, which is called the secondary name node, and aim is only making sure that the image of the name node, of the information of all of the blocks where the block located, is correct. It's a really fairly bad name, because when I first started to work with Hadoop, I thought that a secondary name node was the failover name node, effectively, which is not. Okay, so don't get confused with the name. It's not a failover name node, it's something else. So when we say that it's something which replicates itself, well, that's pretty much how it works, okay? So when you want to copy a file, it goes first, the file goes first to, so when the client goes to the name node and say, okay, I want to copy this file to your HDFS, right? So the name node says, sure, you're going to work with server A. So the client then sends the data to server A, and straight away say, okay, but we need also to replicate this block onto, typically it's a replication of 3. You can change the replication as you want, but typically it's a replication of 3. And it's going to then copy the block onto 2 other servers, okay? And that's how it works. So if you lose one server, or even if you lose 2 servers, the name node is going to detect that you've got a block which is under-replicated, and will make sure that it's copying this block to 2 other extra servers, okay? If, for example, it's just that you've rebooted the node, it doesn't matter. You will have copied the block, and you will have the block 4 times. If you only want to have 3, if you've decided that you want a copy only of 3, the next time that you need some space, it will get rid of one of your blocks which is over-replicated, if you want. Okay? Any question regarding the HDFS part? No? So then the second part is the MapReduce, okay? So MapReduce, it's a framework for developing distributed application across large amount of data. And the idea is really to have the processing to happen really close to your data. Okay, so as we've seen, the block is replicated on top of 3 nodes by default. So when we're going to try to do a MapReduce action, we're going to send it to the server, which got a copy of the data available with them. Okay, so we are trying to not have to copy the data across the network or anything like that. We're always going to try to send it where it goes. Same thing for the MapReduce. We've got few components. We've got a job tracker, and the job tracker is the one who is going to decide which node is going to work, and the task tracker, which is effectively going to do the job. Okay. the job tracker, so when you send a job, the job tracker go to the name node, say which block we want to work on this type of on this data, which servers do have the blocks, and that's where it's going to then send it to the data or to the task tracker who's got the data. Okay. That's pretty much the MapReduce phase. Okay, so we've got first the mapper phase which happened, and we've got the shuffle. Okay, and then after that, when you finish the shuffle, you do the reducer. Be careful, the shuffle phase, it's really network intensive. So because we've got rack awareness in Hadoop, so you can say this cluster is in rack A and that cluster is in rack B. Often for HA purposes, we're thinking, amazing, great. I'm going to put one rack in data center 1, another rack in data center 2, and I will get high availability by splitting my 2 racks in 2 data centers. And it's kind of work until you get onto a large amount of data and you try to do the shuffle across the network and you're bringing down the pipe which is joining you to data center effectively. You're going to flood the pipe. So the advice for now is don't do it. Apparently they are working on doing something in order to fix this kind of problem. Okay? That's pretty much what we've seen earlier, so I'm not going to go to that. So, as I said earlier, MapReduce is something that you write in Java. Most of the time, you can also write an option to write it in Python, but it's most commonly done in Java. There is 2 other tools which have been developed. Pig has been developed at Yahoo, and Hive has been developed at Facebook, in order to give something to the analysts who are not Java expert and still make sense of the data that they've got. Okay? So, Pig, it's a scripting language. Okay? It provides something that they call the Pig Latin, and it's a data flow scripting language kind of thing. So, why use Pig? Well, so what do they say? You've got some file, you want to merge 2 different types of file, and take the top 5 most visited websites for a group of age, 18 to 25. If you do it in MapReduce, that's the amount of code that you need to write. Okay? So they say what? 170 lines of code, 4 hours to write it. If it's me, it's probably 5 days, but you know, I'm a Java coder with Google, so. In Pig, it's 9 lines of code. Okay? So what people tend to say is that you use 75% of the time you use Pig, and when you can't use Pig, then you're going to go and move to something else. Pig also can be extended by some what we call the user-defined function, and this user-defined function can be in any languages. So they can be in Python, they can be in whatever you want to. Okay? So it's really quite convenient to work with. So the idea behind Pig is that MapReduce was too low and SQL was too high. Well, SQL is fairly straightforward, but if you don't know, I guess it's maybe true. Okay, so the Pig Latin is here to go around this issue. There is no need for a schema. You can do join, you can do sort, and you've got, as I mentioned, this UDF. We tend to use Pig a lot when you want to do ETL. Okay, so there's a lot of usage for Hadoop where we store a lot of new data source. Data source could be the weblog, could be the email, could be text form from different query or whatever. And with Pig, we tend to do a lot of ETL of cleaning the data, merging it together, and maybe we're going to then export it back to another RDBMS or to something else. Okay? Pig is made of 3 things. So we've got the Pig Latin, which is the language. You've got a shell, which is called Grunt. I know the IT people, they like to have fun. It's Pig, it's Grunt and everything. It's normal. And then we've got what we call the piggy bank, which is a way for sharing UDF. Okay, so there is quite a lot of UDF which have been defined, and that you can go directly and basically use them directly out of the piggy bank. Okay? Do you have any question regarding Pig? No? It's all clear with Pig? So we've got this friend, which is called Hive. Okay? And Hive is pretty much an SQL-like interface. Okay? So the idea was to become an enterprise data warehouse of Hadoop. I'm not sure we'll get there with Hive, but that's pretty much the idea. It's going to be an SQL-like interface that you can use. So it's called HiveQL. It's based on SQL 92 specification. It's not ANSI SQL, but it's getting there. It's pretty much like a relational database. So you're going to be able to do, a select, star, from, blah, blah, blah. joined by, and everything. Okay, there we go. Here's a different typical, I mean, if you're a bit familiar with SQL, you will probably recognize some standard statement because there is nothing new there, effectively. Okay? So, something which is interesting is that in most organizations, you're probably going to use pig and you're going to also use hive. It's not either one or the other. It's something that you can use together in parallel. Okay? So, hive is a good choice when you want to query data, and especially if you're already familiar with SQL. Pig is, as I was saying earlier, is pretty much good for doing a lot of ETL. Okay? I'm just realizing that I'm going quite fast on my presentation, so I'm just going to go back quickly, and I'm going to speak about some few modes. So then we've got something which we call hash catalog, and as pig and hive can be used exactly in the same organization, we got a way of having the same metadata shared across pig and hive user, because by definition, when you copy data into Hadoop, it's schemaless. Okay, it's on some unstructured data that you put into Hadoop, and it's schemaless. So sometimes when you were working with pig, you were defining your field with a certain name, and the hive user may define them with another sort of name. And the idea of a catalog is to provide a metadata directory where you store all of this information. So when your pig user is speaking to, when you pig and hive use exactly the same metadata information. So when you want to share information across two different teams using two different, one or the other tool, at least you've got a way of having this information being shared easily. Okay? And then we've got also Flume and Scoop that I mentioned earlier. So let's go back to something which is maybe more admin-like, which is Ambari. Okay? So Ambari is a deployment mechanism which is used to deploy Apache, to deploy Hortonworks Data Platform. It's an open source project. You can deploy vanilla Apache as well with that. And the idea the idea behind Ambari is that you're going first to use it to install your cluster. Then you will be able to manage your cluster. And finally, you will be able to monitor not your cluster, but also monitor your job on top of that. Okay, so it's also a way for you to push configuration across different platforms and modify your configuration from one single place. So of course you can do that all with Puppet and Chef and Ansible, and we've all heard about it for the last 2 days. But that's one of the ways. Actually underneath, Ambari is using Puppet in order to do that effectively, but that's another issue. Okay. The beauty of Ambari is that it's got also a REST API, which means that if you've got another solution that you want to integrate with Ambari, you can do that through the REST API. By default, Ambari is coming with a monitoring and performance monitoring and also a monitoring solution embedded as part of it. And the two solutions that we're using is Ganglia and Nagios. Okay? So Ganglia and Nagios are installed by default by Ambari effectively. If you want to use another performance monitoring solution, it's really easy to actually get back the information out of the REST API. For example, so as I mentioned, we've got partnership with Teradata and with Microsoft. And Teradata and Microsoft do have system management solution as well. And when they implement their system management solution, they don't change everything to work with Hortonworks. What they do is actually they integrate through the Ambari interface. So they don't present Ambari to the end user, but they are getting all of the information out of Ambari effectively. Okay? Ambari got created based upon the experience of the team at Yahoo when they were using Hadoop at Yahoo. Basically, that's pretty much, it used to be called Hadoop Yahoo Management Console or something like that, and that's a bit of a rewrite of what they used to have before. Okay? So just to show you that you don't really need to have a lot of skill in order to install a cluster, we're going to install one together. Voilà. Here we go. So what I've done there is that I've installed an Ambari server, and installing an Ambari server is extremely complex. It consists of saying yum install Ambari server, so that's kind of taking skill already. And then the next step is to say Ambari server space setup. And you've got two stupid questions which are being asked. And both you can keep the default. One of them is, do you want to modify the default password for the database? You can choose yes or no. And the other one is, do you accept the Oracle license for the JDK? Because it's going and downloaded the JDK, the Sun JDK, sorry, the Oracle JDK out of the Oracle website, and you've got to press yes in order to validate it. Okay? So that's pretty much what I've just done in order to arrive to this page. Then I did Ambari server start. Again, that's taking quite rocket science. Then I've gone on to the URL, log with the default credential, and I'm presented with this page. Okay, so I'm being asked to give a name for my cluster. I'm quite imaginative, so I'll just use the name of my company. Normally, I've got more imagination, but last night I kind of lost some funerals. I don't know what I did last night, but you know. Then we are being asked for the list of hosts that I want to install my cluster on. Okay, so because I'm lazy, I've already created the list, and I'm just going to do a copy and paste. So here we go. So I've defined, I've got few hosts there which I've written, okay? So I've given them some name which are making sense, like name node and shop tracker and so on and so forth. It doesn't matter, but here we go. All of my hosts got already an SSH key which is being provided. If you don't want to have a shared SSH key, that's fine. It takes a bit more time. You need to first install the agent on top of each node manually. So it's going to be a yum install Ambari agent. Again, it takes a bit of skill. But there, in my case, I've already shared the SSH key because it's actually running on the cloud. So by default, I've got one which is, just need to use the right one. Here we go. That's the wrong one. Here we go. Right. And then I can, if I've got a local repository for my packages, for my Hortonworks packages, then I can select it here and define the different where it's located. It's not my case. And if I want to have a custom place to install my JDK, again, I can modify it here. It's not my case again. Okay, so I'm just going to do register and confirm. And it's going to go to every single node and make sure he can speak with it and start the Ambari agent on top of it. Okay? So bon, it's a demo, it's live, so normally it should break and we should have a big red failure at some point, but you know, let's cross finger for 5 minutes. So I've even, as you can see, I've also embedded as part of it the Ambari server itself as part of the cluster, okay? Because it's also going to become part of the cluster. Luckily, it's saying that it's able to speak with all of the nodes. So then I'm being presented with a list of components. Okay. I'm being presented with a list of components that I may want to install. Okay. So I've got HDFS, I've got my previous. Fair enough. I kind of need those two if I want to do some Hadoop stuff. Then I can, as I mentioned, I've got Nagios and Ganglia, which are available by default. And all of the different components are there, okay? I'm not going to bother, I'm just going to press next, and that's pretty much it. Then it's going to suggest, based upon the amount of servers that I'm going to install my Hadoop cluster on, how do I want to spread my services, okay? So there I only have 7 hosts, apparently. So it's going to try to put as much as possible on 3 nodes. But if I add, let's say, 200 hosts, he will try to split much more the services in order to have something which is much more scalable in the future. Okay, so it's got a bit of intelligence as part of it. The only intelligence it doesn't have is that, for example, it's chosen for one of my servers something which is called data node 1, which is not exactly what I was hoping for. But anyway, it doesn't really matter. It's just a name. So then we press next, and it's asking me where do I want to have HDFS installed on all of the components, yes or no. And as I've also said that I wanted to have a HBase install, it's suggesting to install a region server on every single data node. Whatever, I'm going to say next. Okay. I've got some issue with my mouse today. Ooh. Bon. Either it's the mouse or it's the internet, but one of the two is not too happy. There we go. Voilà. So now I arrive to the last spot, and I can review all of the different configuration files, and I can pass some additional information on top of it. So for example, there I'm in the HDFS configuration. We tend to have a typical Hadoop server for a data node. We'll have a lot of different disks. Those disks won't be readied because we're trying to spread the I/O across all of the local disks at the same time, because we've said that we were happy to lose a disk because HDFS is resilient by itself. So I don't need to have read actually. By having all of the I/O going on at the same in parallel to all of the disks, I'm going to have a better speed in order to access my disk than by having a read device effectively. Okay. So if I had what will typically happen is that if I've got a lot of local disks, each disk, no, that's not on the name node actually, it will be on the data node. Here we go. Each disk will be a specific mount point, and we will try to mount it. We will mention all of the mount point in this folder, for example. There, pretty much, if you're familiar with the HDFS site.xml, you can find hdfssite.com. You can find all of the information that you will find in the configuration file available from the web interface. Okay. Here we go. That's, for example, for HDFS, and it's the same for exactly all of the different options which are available into the solution. Okay. There is, as you can see, there is some red point there, and the red point just means that I've got some input which is expected from me before it's allowing me to go further. I'm going to stop here because there is no need for us to start through an installation of an Ambari server. It's going to go quickly. It's going to take 15 minutes, to install all of the packages and so on and so forth. One of the beauties is that when it finished to install before it starts the service, it's got what we call a smoke solution. And so before it starts HDFS, it's going to run a test to make sure that SDFS is working. No, it starts HDFS, and after it started it, it ran a test to make sure that SDFS is working. Then we'll try to start MapReduce and do exactly the same. We will launch a small test to make sure that MapReduce is working. The same with HBase, the same with Hive, the same with everything. Okay? So I've got one which I'm already running there. Okay? So that's an Ambari server which is monitoring a cluster already. Okay? So it's a 12-node cluster that we've got running on the cloud, I believe. Okay? And from here, I've got access to all of the different services which are available on top of my cloud, okay? So I can click on HDFS, for example, and it will tell me what is my name node, what my second name node is, how much storage do I've got available, what is the current memory usage for the HDFS part, effectively. So it can be, we're trying to provide you with some metrics which are relevant to you. So these metrics are actually stored in Ganglia, and we're just displaying them in the interface, okay? You can also, from this page, so the name node, the task tracker, the job trackers, they all have a standalone web user interface. And from here, you can go directly onto the web user interface of the data node, for example, or the name node to see what's happening, okay? So I can do that for okay. I can do that for my HDFS, but I can also do it for MapReduce, for Hive, and for HCatalog. Okay. There is something else which is interesting. We've got what we call a neat map. Okay, and a neat map will quickly give you a view of how is your cluster doing. For example, there I can see that in this space I've got no issue, everything is green, and it's all good. When I look at the memory usage, I can see that I've got some servers which are slightly more used in terms of memory. So I can have a quick look at what's running on this server and why is it busy, and is it normal that it's so busy. Well, we can see that actually the server is running Ganglia, Nagios, the name node, so one of the most important components, okay? And it's all on one server. We should probably have spread it into multiple servers, and we won't have this issue about memory, okay? But it's a quick, imagine you've got now a really large cluster, and when you look at the disk space, you've got one node which is saying, okay, actually I'm copying a lot of data to this node. It's a quick way of seeing that you may have an issue and you may want to change something or you've got a problem, okay? So it's a good visualization tool, effectively. Then every single service can be stop or start directly from here, okay? So I can stop it, I can start it. I can put a node, because that's what I was mentioning earlier, we can run a smoke test so that's to make sure that my HDFS solution is still working, it's still behaving in exactly the same fashion as I was expecting. And so that's the different information of my HDFS. On the right-hand side, we've got the Nagios alert. Okay, so if we had an issue, so it's some predefined Nagios alert which are available there. And if we had an issue, it will be brought back here. As you can see, there is never any issue with Hortonworks. It's all green. Amazing. And then we've got, again, some of the metrics which are relevant for the HDFS part, for example. Okay? If I want to modify my configuration of HDFS, again, it's something you can do quite easily through the web interface. Most of the time, it's not most of the time actually, it's something that will require to have a restart. So we normally ask you to first stop the services, modify your configuration file, and then restart the services. Okay? So that's the part about how do you manage and how do you configure your host. That's again the host in a different view. But if I click on one physical host, for example, I also have the performance metric coming out of Ganglia just for this physical host. Before, what we are looking at were the cluster of nodes working together. There we are looking at just the metric on one physical host. But that's all about the performance, and there is something else which is available from Ambari, which is the different job which I'm running within my organization. So there's a different MapReduce job which are being run within the organization. So for example, you can see that I've got a job there which is a MapReduce code, I've got a hive script which I've been running, I've got a pig, and so on and so forth. How much data did I took in, how much data did I output it, and so on. Something which is interesting to look at is also the swim lane. Okay, so something I forgot to mention when I spoke about pig and hive is that pig and hive, when you're creating a pig script or when you're writing an hive query, what they're first doing is that they're translating this pig script, or they're translating this hive query into effectively some MapReduce job. Okay? So when you look from the name node, from the job tracker user interface, your pig script has become 5 different MapReduce jobs, so it's sometimes quite hard to track what happened over this time. There, what we're representing is that we're representing, I think it was a pig script that I've clicked on. We're representing those 5, those jobs which have been, we're representing my pig script which has been split into those 5 jobs. Okay, so we can see that, for example, that was my 2 map phase, and then I had probably a shuffle and then some different reduce phase afterwards. Okay, I can have a look at here. But I can also look at where did I spend my time. Okay, so that was first the mapping, the shuffling, and then the reduce stuff. It's got all of the history as well. So if you've got a job which you're running regularly, you can also check that the performance are not being degraded, not degrading. Okay, so that you always have the same performance, and you get all of this information directly from this point, effectively. Okay. And something else that we're going to add is the Hadoop user experience. So I don't know if you're familiar with Yahoo. Yahoo give you with a small web interface which lets you write pig script, which lets you do quite a lot of things. And with Yahoo, it's going to be a new tab that you're going to have available here, and you will be able to effectively have an editor to write your pig script with syntax highlighting and so on and so forth. Okay, so it makes it fairly easy and straightforward to learn how to write pig script at least. There is just maybe one last thing that I would like, if you want to learn a bit more about Hadoop and how to use Hadoop, there is something that Hortonworks does quite well. We've got a sandbox, which is a standalone virtual machine that you can go and download from our website. And as part of this sandbox, you've got a standalone Hadoop, not cluster because it's a standalone node, but you've got an Hadoop environment running. And you also have some tutorials. So on the left-hand side, you've got the tutorial where you can, we're telling you what to do with pig and how to use pig and how to use hive and introducing you to these kind of tools. And on the right, you've got this Hadoop user experience, which lets you do it effectively on the same time. Okay? Do you have any question regarding Ambari or regarding Hadoop effectively? Do you use yourself Hadoop, or did any of you started using Hadoop? You do over there? It's a surprise. No? Any question regarding Hadoop or Ambari, or? No.
Okay, no questions. Thank you very much.